Okay, year 12 and 13. So this is going to be the first video for the independent task for Unit 1. So on this first task, you had surds, discriminants, transformation graphs, and then two coordinate geometry questions, one for lines and one for circles. Okay, so we're going to walk through each of the questions now. So you should have completed them. You should have followed these steps and decided and got to a certain level of support that you needed. Make sure you make a note of that so you know how much extra work and stuff you need to do on those topics. Okay, so first of all, the surds question. Okay, so I got a rectangle has a length of 1 plus root 3, so I'm going to put that on my rectangle. That's one of the lengths, and then it tells me the area is root 12, so my area is equal to root 12. Now, calculate the width, so I need the other length of the rectangle. Okay, now it's important. All I'm going to remember now is that my area is length times width. So I would have times whatever this length is by here by 1 plus root 3, and I would have ended up with root 12. So I'm going to end up with the fact that I've got root 12 should be 1 plus root 3 times the width. I'm going to rearrange. I'm going to divide by this. So I now know that my width is root 12 over 1 plus root 3. Okay, now there's a couple of things we need to do here. First of all, I'm going to look at the root 12 on the top, and I'm going to decide, can I simplify it? So I'm going to go to the side over here, root 12. Well, I know that is root 4 root 3, which is the same as we have in 2 root 3. So I can change the numerator for that. Okay, so I've got 2 root 3, and then I've still got 1 plus root 3 on the bottom. Now, I need to rationalize the denominator. Now, to do this, we're going to times by the conjugate, which is just flipping that sign in the middle. So that's 1 minus root 3 and 1 minus root 3. Now, it's important you do the same to both sides. Okay. Oh, sorry, same to top and bottom. And then we expand them like brackets. So technically, there are some brackets on the top here. So that's a single bracket. And technically, there's a double bracket on the bottom. So the top one, if I do 2 times each of my terms, or sorry, 2 root 3 times each of my terms, I get 2 root 3. And then 2 root 3 times minus root 3. Okay, root 3 times root 3 is 3. Times by another 2 is going to be 6. And it's minus because obviously I've got positive and negative. Now for the denominator, okay, what should happen is my root should cancel. So let's expand these double brackets here. I get 1, put in 1 times 1. Then I get minus root 3. Then I get plus root 3. And I get root 3 times minus root 3 is going to give me negative 3. Now if you notice on the denominator, let's just leave the numerator alone for now. On the denominator, these two simplify and cancel off. So I've got 1 minus 3, which is minus 2. Now, I am just going to divide everything by minus 2, so I get minus root 3, and then minus 6 divided by 2 gives me plus 3, which is the same as me writing it this way around as well, which is in the format they want me to get it in. Okay, so kind of key bits. I used a little bit area form, which was like the extra step, but apart from that, it's a rationalizing the denominator question. Now, make sure we can always check our answers, so we should be able to type this top bit in here into my calculator, and it should spit me out the exact answer. Okay, so always check your answer using that, but don't use it to actually find your answer. Okay, you need to have all these steps for the marks. It's really, really important, otherwise you'll get nothing. Okay, so question 2, we've got discriminants. So as soon as I see a quadratic and it's talking about, well, it's mentioned the word discriminant, but if it's mentioned something about roots, so if you've got real roots, you've got 2 distinct real roots, okay, and we've got no real roots, okay, I know I'm going to use b squared minus 4ac as part of my discriminant from the quadratic. So for the first part, it just wants you to find the discriminant. Now, of this bit here, I'm going to write down what my a is, what my b is, and what my c is. Okay, so a must be 2, b is k plus 4, and c is k. And I'm just going to plug them into my formula. Okay, so I've got b squared, so I've got k plus 4 all squared, minus 4 times a, which is 2, times c, which is k. Okay, now this first bit, I'm just going to expand my brackets. So I get k squared plus 8k, because I'm going to get a 4k and another 4k, and I'm going to get my plus 16. Then this one, if I expand all these, I get minus 8k. Now if I simplify that out, these two are going to cancel, gives me with just k squared plus 16. That's my discriminant for this question. Now I'm going to go over to the side here. Now obviously normally in an exam we'd work down the page and stuff. Okay, I don't have the space. I probably should have given you guys a bit more space as well, but I'm just going to go across for this one. So hence or otherwise prove that it has real roots. Okay, so I'm just trying to prove the fact that it has real roots, not find the actual roots that it has. So it's important that we remember what two distinct real roots are. Now, two distinct real roots, okay, straight away means that b squared minus 4ac must be bigger than 0. So I must have it crossing at 2 points, okay, like this. Now, so I need to basically prove that the equation I've got down here, is my final answer, is always bigger than 0, okay, which it should be, because if we think about this, k squared, okay, if I square any number, doesn't matter if it's positive or negative, will always be bigger than 0. Okay, now since that must be bigger than 0, if I take it, so k squared, whatever it is, and I plus 16, that should always be bigger than 0 as well. Okay, so therefore, h of x has two distinct real roots. Now, for people, I assume quite a few people would have tried to solve it, so would have done something like this. So k squared plus 16 is bigger than 0. Now you would have taken it to the other side and gone, okay, that's minus 16, and realized that you can't square root it. Okay, and probably would have got a little bit stuck here. So it's important that you read the question. Okay, the question wasn't asking you to find the roots, it was just asking you to prove the fact that it does have two distinct real roots, which means I basically need to prove that it's always bigger than 0, which I have done by here. Okay, on to question 3 then. We've got transformations of functions. So the issue with this one is they haven't drawn it for me, so I had to draw it originally. So my function is f of x is x, and now I've got x minus 2 squared, so that means I've got a double bracket here. Now this is a cubic, okay, this here is a cubic, and it's a positive cubic as well, so I know it should have this kind of shape that I've drawn by there. Okay, well I've got, it should take this generic thing by here. Okay, so now the issue is obviously I've got two of the same roots, which means if I draw my axes, okay, this should only cross or touch at 2 points. Now the issue that if I drew it like this, like so lots of them, let me draw that again. Okay, this curve here crosses it at 3 points, okay, which isn't what I'm looking for. So actually, because my roots would be x is 0, because this is when this is 0, and x is 2. Okay, it's going to come up past 0, so it's going to cross 0 here. And then it's just going to touch a 2. Okay, so it should look something like this. Now I should draw my dot a little bit over, that's fine. I can just move it over, that's 2, that's 0. Okay, that's what my graph should look like. It doesn't cross over, it just touches the x-axis at that point. Okay, so now for the next bit, let me rub this off. For the next one, it wants me to do f of x plus 3. Now if I do f of x plus 3, now first of all, the first thing we need to spot is this is in the brackets. So it's going to affect the x coordinates. Okay, now not only does it affect the x coordinates, it does the opposite. So I'm going to take away 3. So all that is going to do is going to pick up my whole graph and it's going to shift it 3 places to the left. So instead of crossing at 0, it's going to cross at minus 3. And instead of touching it at 2, it's going to touch it at minus 1. Okay, so actually, let me get rid of my minus 3 so I can draw through it. So again, it's going to come up, it's going to come back down, it's going to touch it at 1, and it's going to jump up again. Okay, so there's my 0. Oh, sorry, not 0, minus 3. Okay, if it was outside the brackets, it would have affected my y coordinates, and it does as it says, but if it's in the brackets, you've got to do the opposites. Okay, now on to the two probably longer questions, okay, my coordinate geometry ones. So this one is quite a lot of information to deal with, and we've got to deal with it bit by bit. So the first thing is line L has the equation. So L has the equation of 2x minus y minus 1 is 0. Okay, now the line M passes through the points 0, 4 and is perpendicular to line L. Okay, so what I need to do first, I need to find the gradient of L. So what I'm going to do is I'm going to rearrange this equation so that it's y equals. Okay, to do that, I should get 2x minus 1. Okay, that's me just taking the y over to the right-hand side, okay? So from this, I now know the gradient of this, so gradient of L is 2. Okay, I can just pick it off the y equals mx plus c. So if you need to pick it out, try and get it in the form of y equals mx plus c, and then you can just pick your equation off, okay? So next bit is I can now find what the gradient of m is. Okay, now your perpendicular lines, your gradient, so m1 times m2, should equal -1. Now the quick way of doing it is I flip the fraction, so this becomes a half, and you've changed the sign, so it's minus a half. Okay, now I can use, so I'm going to be using the equation, so y minus y1 is m x minus x1. Okay, I'm basically going to sub my values in. So I've got y minus the y coordinate, which is 4, is minus a half x minus 0. Okay, now I don't like the half, so let's times this left-hand side by 2, so that's 2y minus 8 is minus x. I'm timed by this by negative as well. I'm basically going to rearrange it. Now, I'm going to take it all onto one side like they had it. So I've got 2y plus x minus 8 is 0. Okay, now it doesn't really matter. It hasn't asked for it in a certain form. So if I left it like this, I would have got the marks. Now, part B, show that lines L and M intersect at the point P, which is 2, 3. Now, if I've got two lines, or if I want to see where they intersect, I need to do simultaneous equations. So line L is currently, what did they give me? They gave me 2x minus y minus 1 is 0. So let me just rearrange that again. So it's 2x minus y is 1. Let me take line M, and let's make it M, which is this equation down here, look the same. Okay? So I've got, get rid of those. So I've got x plus 2y is equal to 8 if I rearrange that in another format. Okay, now here's equation 1, here's equation 2. I need to do some simultaneous equations. So I'm going to times the second one by 2. So I get 2x plus 4y is 16. That's going to be my equation 3. And I'm going to do equation 3 take away equation 1. Okay, so 2x take away 2x is nothing. 4y take away negative y is 5y. And I get 15. So y must be 3. Then I'm going to sub into number 1. I'm going to solve number 1. So I get x plus 6 is 8. So x must be 2. Therefore, L and M intersect at 2, 3, which is what they wanted me to show. Right, now, let me see if I can draw. Let's draw a straight line. So straight as my line is going to get there. Okay, so part C, quite a big thing now. And I've now got a new line, N, that passes through the points B, 3, 0, and is parallel to M. Okay, so straight away I know what the gradient is. Must be minus a half, because it's going to be the same gradient if it's parallel. Find the coordinates of the point of intersection of L and N. Okay, so I need the equation for N first. So again, there's my gradients. I'm going to use my lines of y minus y1 is m x minus x1. I'll plug my values in. So y minus nothing is minus a half x minus 3. Okay, times by 2, so 2y is minus x plus 3. Because I want to times by everything by negative. And let's rearrange equations. So I've got 2, so I've got x first. I've got x plus 2y is 3. Okay, there's one equation. That's the line for n. And let's call that number 1. Then line L we got in the form of 2x minus y is 1. This is equation 2. I'm just going to follow the same steps. This time the top one by 2. Let me do that. Short enough space. I'm going to times the top one by 2. So I get 2x plus 4y is 6. That's equation 3. Same thing again. Let's do 3, take away 2. Gives me 5y is 5. So y must be 1. And then let's sub it into number 1. It's going to give me x plus 2 is 3. So x must also be 1. So therefore, intersect at 1, 1. Okay, so the initial bit was only the extra bit. It wasn't actually much more work than what we'd already done. I just had to form my equation in the first place. Now remember, if they're perpendicular, your gradient should multiply to make -1. If they're parallel, they should have the same gradient. Now, so that's where they intersect at. One more question. Okay, and this is quite a difficult one. Okay, now quite often they mix some circle theorems in to your coordinate geometry for circles, and they have done here, okay, in a little bit sneaky way. So it's important to understand what to look for. Okay, so I've drawn a I've drawn a diagram for this one. So I've got point A is -3, -2, point B is -6, 0, and point C is 1, Q. Line on the circumference of the circle, such that BAC, so this angle down here, A, is 90 degrees. Now for that to be 90, BC must be the diameter. Okay, because you've got an angle subtended in the semicircle should be 90 degrees. A is 90 degrees, which means BC must be the diameter. So if I want to find Q, okay, I want to find this value up here. I've just got a right angle triangle here. So I could try and just use some Pythagorean trick. Now I don't know any angles apart from the right angle. Okay, so I'm going to go with Pythag. Okay, I'm going to use Pythagoras as much as I possibly can here. So to do that, I need to find each length. So the first length I'm going to find is AB. Okay, now we know how to do lengths of lines using our formula. So I've got -6 minus, and then take the other exponent, -3 squared, plus 0 minus -2 squared. Okay, I plug that in, I get root 13. Okay, and I'm going to complete that for every line now. Okay, so the next two are going to include some algebra, so I've just got to be a little bit careful here. Let me move that up so I make sure I've got enough space. So it's going to be root 13. Okay, that's one amount, so let me highlight that. Next one I'm going to do is going to be BC, which is going to be, if I put my big roots in place, there we go. So I've got 1 minus -6 squared, and then I've got Q plus Q minus 0 squared. Okay, now I'm going to simplify this as much as I can. So 1 minus -6 is 7, square it gives me 49, plus Q squared, and I've still got that square rooted. Okay, I can't square root them both, that's not how it works. I've got to leave the root on it. Okay, we should see something really nice happen in the moment with all these roots, okay, because they're not looking very nice at the moment. And the only other length I need to find is AC. And again, I'm just going to go into my formula. So I'm going to have 1 minus -3, and then that's squared. Plus, I'm going to have Q minus -2 squared. Okay, now the first bracket, take my pen, there we go. First bracket is going to be 4, squaring it gives me 16. Okay, so I'll put my roots in a minute, so let me do all the way across. This one, this bracket here, should be Q plus 2 squared. Okay, so I'm gonna also expand this double bracket here. So I get plus Q squared plus 4Q plus 4. Okay, if I expand this double bracket, so let me go to that. And I can simplify this up a little bit. So I've got the root of Q squared plus 4Q plus 20. Okay, now that none of those three things look very nice at the moment, but if I apply Pythag, okay, all I'm going to do here is I'm going to do, okay, BC squares alongside, so I just have BC squared is AC squared plus AB squared. Now, when I do square these, if I square each of these, the roots are going to disappear. So when I do BC squared, that's going to get rid of the root. So I've got 49 plus Q squared. Okay, I've completely got rid of the root there. AC squared is going to be Q squared plus 4Q plus 20, because that's got rid of my roots. And then, plus 20, sorry. And then plus AB squared is going to be just 13. Okay, and I can simplify this out. Look, they both got a Q squared. Okay, so if I take things to one side, Q squared and Q squared are getting rid of each other, which allows me to go, okay, I've got 4Q, change colour, there we go. I've got 4Q. If I take everything else to the other side, so I take away 20 and I take away 13, I get 16, which means Q must be 4. Okay, so what I'm going to do to help myself here is I'm going to change this to 1, 4. So quite a difficult thing to notice we need to use, but we've got a right angle triangle. Okay, so why not use some Pythagoras? Now, for the next one, I want the equation for the circle. So for an equation for the circle, part B, I need to know what's its centre, and I also need to know what's its radius. Okay, now, its centre should be the midpoint between B and C. Should be by here somewhere. Okay, so I'm going to do some midpoints here. So notice I'm mixing up some of my line coordinates, okay, and some of my circle rules, okay, to help me here. So I got a midpoint here. So that should be -6 plus 1 all over 2. And then my y coordinate should be 0 plus 4 all over 2. Okay, if I do this, this could be 5 over 2 or 2.5. If you've got that instead, that's fine. And then 2. Okay, that's my center. Now the other thing I need is the radius. Now the radius should be half of BC. Okay, which should be a half times by, again, the length which I go over there. So 49 minus Q squared, so plus Q squared, so plus 16. Okay, if I plug that into my calculator, I get root 65 over 2. Okay, so I've got my two bits. There's my center, there's my radius. I'm now going to use my equation for a circle. So I've got x minus x1 squared plus y minus y1 squared. So that should be minus 5 over 2 equals r squared. Okay, that's my equation. So I've got x plus 5 over 2, because I've got a minus and minus, squared, plus y minus 2 squared. I'm going to square this. That gives me 65 over 4. And there's my equation for my circle. It hasn't asked me to expand it or put it into a certain format, so I can just leave it like that. So make sure you've marked all of that. If you needed this for a little bit more walkthrough, that's fine. But remember to think about what level of support and what topics you now need to go over.